Welcome to video lesson number 15. Today's lesson is on the properties of mathematics. For today's lesson, you're going to need the notes you were given in class, which is TOC number 15, a pen or pencil, of course, as always, to take notes. You may want to grab something with color, like a highlighter or marker, colored pencil, so that you can star some things and highlight keywords. And this is part of the calculator section, although you really won't need it for this topic. For properties of mathematics, this is really just a topic you're going to memorize. There's not a lot of math that you have to do. It's just looking at, if you're given a math problem, can you look at it and say what property is being used here? And properties are just the rules of mathematics that we use that allow us to do certain things. For the commutative property, this works with only addition or multiplication. It does not work with subtraction or division. And you've learned about the commutative property before in elementary school, so this should be something that you're familiar with. So commutative property simply says that you can change the order of the numbers and it won't change the answer. So since it's addition and multiplication, it doesn't change the sum and it doesn't change the product. So a practical example of this is every day I start my day at home and I commute or drive to school. Commuting is our drive to work every day. Parents commute to work every day. At the end of the day, I drive from school to home. And it doesn't matter which direction I'm going, I'm always driving the same distance. So I would always have that same mileage that I drove. But it doesn't matter if I'm going from home to school or school to home. So if you look at the examples up here on the right, we have 3 plus 2 plus 1. And if I were to add those all up together, I get 6. Well, I can change the order and do 1 plus 2 plus 3. And 1 plus 2 is 3. 3 plus 3 is still 6. It doesn't matter which order I add them in. It just, as long as I'm adding the same numbers, I'm going to get the same answer. And it also works for multiplication. So I could go 5 times 8 times 7, or I can do 8 times 7 times 5. So it doesn't matter which order I multiply them in. And this helps us with mental math because there may be certain ones you're more familiar with your factors that you can multiply easier. And the last example here is one that they're going to get you on. So you may want to put a little star by it. 5 plus A is in parentheses plus B. And they throw this in because you've all seen the associative property before. And the associative property has parentheses. And so you're going to see those parentheses and you're going to go, oh, it's the associative property. Look at the parentheses. If they do this, and 5 plus A is in parentheses on both sides, then it is not the associative property. I'm not changing what's in parentheses. I'm only changing the order of where the parentheses are located. So in this case, the parentheses and B switched places. For associative property, so associative, again, also works with addition and multiplication only, not division or subtraction. And it is regrouping or changing the numbers that are in the groups, the grouping symbols, does not change the answer. And a way to remember it is your associates are your friends. So if you look at the example down below, we have Amber, we have Sydney, and we have Barbie. If Amber and Sydney are going to the mall together, they're in a group. And they're going to the mall together. And Barbie's kind of off on her own, staying at home. But the next week, Amber can't go because she's got homework, and Cindy and Barbie go as a group to the mall. They're all still friends. They're still going to give you that same result, but who they're going to the mall with, who's in their group, changes from day to day. So if you look at the examples up on the right, we have in parentheses 3 plus 2 plus 1, and in this case 3 plus 2 are best friends, but then we can flip it and say, okay, well, Maybe 2 plus 1 need to be best friends, and 3 is kind of on the outs. You can also think of it as boyfriend, girlfriend, who's dating who, because that changes in middle school quite often. So if you look at the second example with multiplication, we have 5 times 8 times 7, and 8 times 7 are dating in the group, or in their group. So if we were to change that, I would put 5 times 8 in the group, and then 7 would be on the outside. So all you're doing is moving your parentheses to put different numbers grouped together. And the reason why we do that, and why it's a property of mathematics, is because it is easier sometimes to group things and say do this first. So looking at 5 times 8 times 7, 8 times 7 is 56. I do not want to multiply 56 times 5 because it's hard. I'd have to sit there and write it out. But if I move my parentheses and do 5 times 8 first, that's 40. And I can mentally do 40 times 7 because 4 times 7 is 28, and add a 0 and get 280. So you use properties of mathematics to make your math calculations easier. And they're just different rules that you can use to help you with mental math. Sometimes your examples are going to have just letters. So if you look at the last example, we have A plus B plus C, and B plus C is in parentheses, or dating. We can change, maybe C did something wrong, so now A is going to date B, and B is going to go out with A. All right, so associates are your dating rules, or your friends, however you want to remember that, but that's changing who's in your group, or who's in your little posse. All right, the additive identity property, this is new. In this one, there are two identity properties. One's adding and one's multiplying. They call it additive and multiplicative. For the additive identity, we break it up because you're not doing the same thing. So with the additive identity, think of your ID. Doesn't matter if you change your clothes, you're still yourself. So the number is still going to stay the same on both sides. So in order to keep the number the same, we add a 0, and that keeps the number the same on both sides of the equation. So, and I like the little saying, I am who I am, and that's my ID, my identity. So if we look at the example on the other side, 3 plus 0 is still going to keep its same identity. It's still going to stay 3. And here's a more complicated one. You have 25 times 0 plus 4. Well, 0 plus 4 is still going to be 4. So then when you do that, you would get 100. So it's just a way of thinking anything plus 0 is going to stay the same. You know this. It's nothing new. We're just giving it a name. So you know that this is a rule that says anytime you add 0 to a number, the number stays the same. We have the same thing for the multiplicative identity, but instead of adding 0, because we're not adding anything, we got to think, what number can I multiply times another number and keep the answer the same? So in this case, it's multiplying any number by 1 will not change the identity or value of the number. Again, it's I am who I am, my ID doesn't change. The clothing, the numbers may change, but anytime you multiply by 1, that number is going to stay the same. So 22 times 1 is 22, and then if you look at the second example, we have 55 plus 5 times 1. Order of operations says I do 5 times 1 first. Anything times 1 is still just the same number, so we get 55 plus 5, because 5 times 1 is 5, and then add that together and get 60. So you may see some complicated equations with this where you have to do multiple steps. Just know that they're looking for what operation or what property is being used to allow you to do that. For the inverse property, well, inverse, if I do something and it's the inverse, it's like having something inside out or opposite or undoing something. So we're going to think of it as adding. With adding, it's adding the opposite of the number, which means you're going to look at the positive and the negative, and that will undo the number, and it equals 0. On the additive identity property, we're adding 0, but on the additive inverse property, we equal 0. So look at your examples on the right. We have 6 plus -6, and that's going to equal 0. If I have a -9 and I add a number to it, what number would I need to add to get 0? Well, the opposite of -9 is a +9, so it would just be +9. And I want you to put a star by the additive inverse property, because this is one of those that you're going to get mixed up on. They get identity and an inverse property mixed up the most, so put a star next to inverse property. It is one of the new properties that you have to know, and it is one of those that you get tripped up on. And for multiplicative inverse property, this one's a little bit different, but we've been doing this because we use the reciprocal when we divided fractions. And so this is just saying that if I undo a number using multiplication, I multiply the number by the reciprocal, or the flip. I flip that fraction upside down. And this equals 1, not 0. Underline not 0, because it's important that you know your answer is not going to be 0. With additive inverse, you get 0. Multiplicative inverse, you get 1. So if you think of 3 times 1/3, the inverse of 3, we put that over 1, and then we flip it upside down and we get 1/3, and that will give us 1, because we get 3 times 1 is 3, 1 times 3 is 3, we get 3 over 3, that gives us just 1. So what would my reciprocal be of 3/7? The answer should be 7/3. So just know that you're taking the fraction, or if it's a whole number, put it over 1, and then flip it upside down, and when you multiply those out, you get the same number on top and bottom in your numerator and denominator, and when you do that, that equals 1 whole. So if you look at the second example, we have 3 times 7, that would give you 21. 7 times 3 would be in your denominator, which also equals 21. When you have the same number on the numerator and the denominator, that is a whole. All right, we also have the multiplicative property of 0, which is a fancy way of saying 0 is the hero, and that multiplying any number times 0 will result in an answer of 0. So that's all you have to know. 0 is the hero with multiplication. So 15 times 0 is 0. 29 times 0 is 0. Anything times 0 is 0. Again, you know this. There's nothing new, we're just putting a name to it. Distributive property, this is one I want you to put a little notation, a star next to it, something, and then write not on your test. This is not part of your SOL, but you do need to be able to remember this because you were taught this in 5th grade. But it's important that you know that it's not going to be on your SOL. But they may throw examples in there, so you may see it. Just know that this would not be one that you select as an answer. So the distributive property says that I'm going to share everything outside the parentheses with all the numbers inside the parentheses. And when we say share, we mean multiply. So if you look at the example down at the bottom, we have the Angry Birds. The blue Angry Bird is going to get shot, and he's going to hit the pig with the helmet and the pig without the helmet. So he's getting shared, multiplied by both, to both equally. Like a teacher in your class, she's not going to give candy only to one person. She's got to make sure she shares with everybody in the class. Or if you bring in cupcakes, you can't just bring in cupcakes for one child in your class. You have to bring it in for everybody. So look at your example up above. We have 2 times the quantity A plus B, which means 2 times A plus 2 times B. And then the second example, same thing, but this time I solved the second part. We have 5 times A, which is just 5A, can't write it any other way, and 5 times 2, which we all know is 10. And now it's time to show what you know. So go ahead and log in and take your homework quiz.